Hi there, this is Florian from the Post Partnerships and Integrations team at Netflix, and I will give you a very brief introduction to IMF. I will first explain what IMF actually is and talk about the problem that it is trying to solve. I will then discuss the high-level structure of an IMF package and talk about the benefits that it provides. What is IMF? IMF stands for Interoperable Master Format. It is what we call a componentized media format. What that means is IMF does not save sound and picture data in a single file the way traditional formats like MPEG-2 do. Instead, sound, picture, and time text are all stored in separate files, and an additional mechanism is used to combine and to synchronize these separate components for playback or processing. IMF is very similar to the format that has been used for digital cinema distribution for a good 10 years already. Just like the digital cinema format, IMF is standardized by the Society of Motion Picture and Television Engineers, short SEMT. The standard is split up into two groups. A few documents define the core framework and the fundamental mechanisms within IMF. They set the basic rules. The other group of documents defines individual IMF applications. These applications are targeted at different use cases and mainly differ in the image compression codec used. The specific flavor that we use at Netflix is IMF Application 2 Extended, short AP2E. It meets our requirements and uses JPEG 2000 for image compression, just like digital cinema. IMF AP2E has built-in support for high dynamic range, high frame rates, and time text, and it is currently being updated to support resolutions up to 8K. Thanks to its design, IMF also allows support for new technologies to be added in form of plugins. Two such plugins are currently under development to support immersive audio and dynamic HDR metadata in IMF. Okay, so that all sounds great, but why do we need it? Let's now look at two challenges that we're facing today or will face in the future. The first one is about replacing a shot or a few frames that were flagged during QC. Examples for common issues that we see in the picture track are dead pixels or visible production equipment. Traditionally, the entire program or at least the entire picture track would have to be redelivered, even if only a very small part of it needs to be replaced. We will have a look at how IMF improves this workflow in just a moment. The second challenge that I would like to point out is versioning. For us as a global company, localization of content is crucial in order to provide consumers around the world with a great viewing experience. We therefore provide time text and dubbed audio in a variety of languages. When looking at localized picture, it becomes apparent that different versions often share most of the picture track and only differ when creative text is visible on screen. Nevertheless, traditional media formats require the full program or picture track to be stored for every single version. In order to create certain content versions, mastering operators align and combine all picture and sound essences before exporting a media file. It's just like mixing ingredients and baking a cake. This is where componentized media formats work different. IMF packages consist of track files that carry picture, sound, and time text essences, as well as metadata files that describe how these essences are combined to create certain versions. You could say they contain ingredients and recipes rather than baked results. Let's now look at the structure of an actual IMF package. A package consists of a number of different files. MXF track files contain the actual picture, sound, and time text essences. In addition to those track files, there are one or more composition playlist files. A composition playlist, or CPL for short, is an XML file that assembles the track files on a timeline to create a composition. The packing list is a list of all the files within a package. it provides technical information like hash values for those files. The asset map translates between asset identifiers that are used within an IMF structure and actual file names on storage systems. So-called output profile lists can contain additional instructions for downstream processing of compositions. Let's look at how IMF can streamline a versioning workflow and how we already use it to deliver fixes. On screen you see a visual representation of assets for a Stranger Things episode. We are currently looking at the original language CPL that calls for the original language video track and the original language audio track to be played back in sync from beginning to end. Here we're looking at a potential Chinese language version of the same episode. This localized version would be defined in a new CPL that is replacing the entire audio track with the Chinese dubbed version. The picture track, however, does only need changes in a few sections that have on-screen creative text. The Chinese version IMF package would therefore only contain the necessary inserts and tracks marked in blue, along with a CPL that reuses the original version picture track for the most part. Getting back to the earlier example where a few frames within the program were flagged in QC and need to be replaced. Instead of encoding and delivering the entire program after fixing those frames, IMF allows to only deliver the affected frames along with a new CPL that specifies how to incorporate the fix into the original version. Again, the delivery with the fix does only contain the insert marked in blue. The red parts of picture and soundtrack represent materials from the original submission that can be reused. To conclude, what are the big benefits of IMF? First of all, IMF is an open and extensible standard which makes it future-proof and enables independent implementations. It is also a very well-defined format that carries lots of metadata. This allows us to run extensible checks during ingest of packages into our ecosystem. Its powerful versioning mechanism enables a faster and more lightweight turnaround for both fixes and versions of content. Because subsequent content versions often reuse many parts of an original submission, IMF can save storage space and processing time.